Hello, this is a quick demonstration of how you can use data mining in Weka. Weka is a freely available software that you can download from the web by simple Google search. Once you download it, you will see this icon for Weka, and you can actually use various data mining algorithms in Weka that are available in Weka. Today I will demonstrate how you can use two of our algorithms, decision tree forest building algorithms called SysFor and ForestPA in Weka, and how you can discover knowledge on various data sets and also make predictions for future. So once you click on this Weka icon, the Weka software will start, and this will be your first Weka page, which is a Weka GUI chooser. In order to use our techniques in Weka, you need to go to the package manager to install our algorithms in Weka, and you need to do a refresh repository cache to make sure that all Weka packages are available before you look for them. So at this stage, you can search for our techniques, which is one of them is SysFor, and then you will find SysFor there. And after that, you need to install SysFor. After that installation is done, you can possibly search for our second algorithm available in Weka, which is ForestPA. Maybe you need to restart. So after your first installation of SysFor, you need to restart Weka, because after every installation Weka needs to be restarted, and then search for ForestPA, and you will see the ForestPA package. Next you need to install this one as well. Once this installation is done, you will see that ForestPay is there, SysFor is there. So you need to restart Weka again. So I'm restarting Weka again after the installations. It's coming up. Now we need to go to Explorer, Weka Explorer. Now you are ready to use your Weka software on various data sets. The first thing, of course, you need to upload a data set, the data set that you want to use for knowledge discovery or building decision trees, etc. So you go to open file. You know your data set, but I can actually also download any available data set already in Weka. So in the Weka software that you have just downloaded a few minutes ago also comes up with some data sets in it. So you go to the data page, and there are a lot of data sets. The extension of these data sets are ARFF. It is very similar to any .txt or CSV data set. So here we have a data set called diabetes data set. So we just open the diabetes data set, and then it shows up the attributes of the data set. This is the class attribute, and this is tested negative or tested positive. So whether a patient has diabetes or not. And you can see the distribution of the classes. So the negative, tested negative 500. So there are 500 records. So the blue is negative and the red is positive. So you have diabetes. A patient has diabetes or not, that sort of thing. Now this is the data set. But now if I want to build classifiers, I need to go to classify and choose classifiers. And if we are looking for tree type classifier, remember we just installed SysFor a few minutes ago. So when we try to choose classifiers, we can see SysFor. We can also see ForestPA. So ForestPA is also available. So you can build either SysFor or ForestPA. You can build multiple of them. So let us first show how to do SysFor, and then this is our data set. We have our data set, that's the diabetes data set, and now we are classifying that data set by SysFor. SysFor has some default setups. You can actually have a look. For example, here minimum number of record in a leaf is 10. We can make it 20. number of trees are 60. The more the better for prediction accuracy generally speaking. So let us, for simplicity, make it 10 to start with, and then start. So here what will happen is immediately it will build 10 trees. So you can see tree number 10, and this is tree number 9, 8, and so on and so forth. So what it does, this tree number 1, I will explain what does it do. It says the plus is an attribute. If you look at the class, the data set details, you will see that plus was an attribute. This is plus attribute, and the distribution of plus attribute is like this. So red is diabetes and blue is not diabetes. So you can see that plus value, when it goes higher, then the chance of diabetes is high. When the plus value is low, then the chance of diabetes is low, red is low, that sort of thing. But it is very difficult to identify these things in plain eyes. Now we can back check it, cross check it, because we can see that the tree has identified plus. So it says that if plus value is less than 166.5 and the mass value is less than 26.3, then tested negative. That means the high chance that the patient will not have diabetes, and there are 159 such cases that has plus less than this and mass less than this, and only 9 of them are actually tested positive. So 150 over 159, that many records do not have negative. So this is a knowledge that you can discover. You can study this for further knowledge discovery, and you can build many trees. You can actually build as many trees as you like. Say, for example, number of trees, you could say 100, and you restart it, then you see that there are 100 trees now, tree number 99 and tree number 100. So you have built 100 trees, and again you can also see what is the accuracy of this prediction on tenfold cross validation, etc. Similarly, if you want to use Forest PA, our Forest PA algorithm, you can also do that. And Forest PA algorithm also has some default setting. Number of trees 10, you can make it 100 or 500, as many as you want. And simple cart minimum number of records 2, you can make it 20, and all these things, and then you can build your Forest PA algorithm as well. So here now you have 10 different trees again, and tree number 0 is the first tree, and this is a Forest PA tree. Okay, and you can see knowledge from here. If age is less than 27, tested negative, the chance is high that the patient will be negative, which makes sense. Younger people generally do not have diabetes. So this is how you can use different classification algorithms to build decision trees from Weka. Thank you very much. Thanks for watching.